At some point in time in your studies of engineering, you're going to come across this principle of conservation of energy. And you typically see this question that is used to teach the concept. What we're going to do today in this video is to dissect the principle step by step using this question. So what we have here is a pile driver and its mass is 600 kilograms. So that's the mass there. It's going to fall from a height of 2 meters. And it's going to hit this pile of a mass 250 kilograms. Now, after the impact, some amount of energy will be lost to either sound or heat, and that amount here is 5 kilojoules. Now, what we need to do is to basically determine the common velocity immediately after impact and the average resistance of the ground. Now together they are going to travel 250 millimeters. So let's get into the step-by-step solution here. Now, one of the first principles that you will come across is that energy cannot be created or destroyed. It can only be converted from one form to the next. And with that, we're going to establish that potential energy will be equal to kinetic energy, and as such we can equate the two formulas. So if we say for potential energy, it's mass times gravity and multiplied by height, which is equal to our kinetic energy formula, which is half our mass times velocity squared. Now the purpose of doing this is to find out what the velocity of the pile driver will be, and to do that, what we can do here is to take out the masses, because mass is common to both of these. So if we cancel the masses, then what we're just left with is gravity times height equals half v squared. And if we rearrange this formula to get v as the subject, then what we get is just the square root of 2 times gravity times by height. So what this enables us to do now is to calculate the velocity of the driver. So let's substitute. So it's important to note that this 2 is the height that the driver is falling from. So we get a velocity here of 6.26 meters per second. So this here is representing the velocity of the driver. So to get the velocity just after impact, what we have to do is find the kinetic energy just before the impact. So this here is going to represent the kinetic energy just before the impact. So we'll use the same formula, half mv squared. So that's half times the mass of the driver, which is 600 kilograms, multiplied by the velocity that we just calculated. So just before impact, what we get is 11.772 kilojoules. So remember, this is like microseconds before impact, just before the impact. So what we need to do next is to calculate the energy that remains after a loss to sound and heat. And this will be quite straightforward. So this will still be a measure of kinetic energy, but the difference is after. So what we do is our previously calculated kinetic energy just before impact, we're going to subtract this 5 kilojoules that's lost to sound and heat. So what we're left with is 6.772, and that's kilojoules. So this is what we have left after we've lost some amount of energy to sound and heat. So at this point we have a combined mass because our two objects are now together. It's an inelastic collision, so they are together now. So we should have a combined mass of the two, and that will be the 600 for the pile driver plus the 250 kilo for the pile. So the combined mass now is 850 kilograms. And what we're going to do with this 850 kilograms is go back to our initial formula which is our kinetic energy formula again. So we're going to still be using our half m, but because this is a combined mass, I'm just going to use u to differentiate the two. So this is representing the combined mass. So half m u squared. U still represents velocity. So we're going to find what the velocity is now of both of these objects going through the ground. So we have our kinetic energy, which was 6.772 kilojoules. So times 10 to the power of 3. That's equal to half. Now we're using our combined mass. So times by 850 times by the unknown velocity of both of these two. So times by u squared. So if we rearrange this quickly, then we get what the combined velocity is. So that will be 2 multiplied by our 6.772 times 10 to the power of 3, and all divided by our combined mass. So then our combined velocity here is 3.99 meters per second. So that's the pace at which the driver and the pile is going through the ground. So that is our common velocity. So that's part A done. Now part B is going to be a bit more straightforward. So let's go through that. So for part B, we're finding the average resistance of the ground. Now to do this, let's establish a few things here. So we know that kinetic energy is equal to potential energy, but it's also equal to work done. So it's the same units really. And for work done, our formula is generally force multiplied by some form of displacement. In this instance, our force is going to be the resistance force, so Fr for resistance, multiplied by the distance moved through the ground. So what we are after, we need to find the resisting force. So if we rearrange this formula, if we get our Fr, then that's going to be equal to our kinetic energy, which we calculated previously. So that's 6.772 times 10 to the power of 3 divided by the distance moved, which was 250 millimeters. So to write that in meters, 0.250. So our final answer then for the resisting force is 27.1 kilonewton. So that's representing our resisting force. So I hope this video helps, and I will see you in the next one.